When we look at the night sky, it is very easy to believe that space appears. It was a quiet place with hardly any drama happening. But if we were to visualize the universe on a big map, it will be possible to see some truly amazing things. It will truly be an amazing sight. Imagine what this more expansive phenomenon could look like in explored parts of space. Like an explosion, it can be compared to some global processes in the universe, or release energy as powerful as the virtual Big Bang itself. The first thing in outer space. Let's actually define what the Big Bang is. We appreciate the amount of force that has been released in this process. Describes the concept of the phenomenon referred to, the accepted cosmological model of evolution and formation, and the initial life of the universe, meaning the beginning of the expansion of the universe. After an indefinite period of being in a singularity, the singularity state is the state of the universe when it had a large energy density. The curve of space-time was sharp. These numbers reached the values of Planck's constant. It is the smallest unit of energy, the joule, multiplied by the unit of time too. On the other hand, it is said that Big Bang, it was the starting point for the process of creating and releasing this energy. This event cannot be like a stick of dynamite, which starts from empty space. Besides, it happens literally everywhere at the same time. It is hardly possible to determine the center. It is really difficult to say with certainty how it actually happened. What did he look like? But one thing is clear. This was a final event of enormous proportions. We are talking about an explosion that is considered to have shaped the entire universe. Its accuracy was beyond imagination. It can only be achieved through the power of a great creator. Through centuries of space observation history, science has not recorded any other event similar in its dimensions. However, as our technologies become more advanced, scientists realize there are some events that happen in deep space, and it's strong, so much so that it seems that all current models need scrutiny. One of these breakthrough discoveries was gamma-ray bursts, OGRPs. The term traditionally refers to large-scale energy emissions into space. It is actually a daily occurrence in the universe. Gamma-ray bursts are the most powerful explosions known to science, occurring in space. And shockingly, the energy is released in a few seconds, equal to that released by the Sun in 10 billion years. It was impossible to record ray bursts for 30 years. Although some attempts revealed the exact location of the source, where the sources were always scattered, it was not repeated in one place. The explosion did not leave any traces, neither near nor far. It was the best that scientists could do. It is identifying some really distant galaxies, where the explosion was recorded. Only in the year 1968, scientists would have known exactly the phenomenon of ray explosions. All credit goes to the satellites. For the US Air Force, its mission was to detect possible nuclear tests in the atmosphere. According to today's views, X-ray explosions occur when massive stars turn into supernovas. It folds into black holes. A powerful stream of charged particles explodes from the surroundings of the hill. When interacting with magnetic fields and cosmic radiation, these particles produce bright rays. As a result of this flow, it is considered a stream, strong gamma rays, so much so that such events, it can be easily detected by satellites. Even though it had happened several billion light-years away. On the other hand, it cannot be recorded by ground telescopes because of the atmosphere that permanently absorbs these rays. The amount of energy emitted during a ray explosion may reach a peak to an indescribable number. If an event of such horrific proportions occurred near a planet, it would be like an atomic bomb exploding in every hectare of sky. Of course, it is almost certain that living organisms will die immediately. That gamma-ray explosion capable of annihilating any life within a radius of dozens, but hundreds of light years. It seriously affects the planetary biosphere within a radius of thousands of light years. Fortunately, these explosions occur at very long distances from us. For example, one of the most powerful radiation explosions ever recorded was discovered, which is called GRP 180. 720, which is more than 4 billion light-years away from us. This means that its light has spent about a third of the universe's life until he reached the ground. As for the amount of energy in a ray explosion, it ranges from 200 to 1,000 billion electron volts. For comparison purposes only, the energy of visible light is in the range from 1 to 3 MeV. At a distance of tens of thousands of light years, it makes the rays explode brighter in this range, practically harmless. But 1 in 100 or 1,000 flares in a galaxy. It happens close enough to a planet. What constitutes a threat? Terrifying when talking about a threat to our planet. Scientists still disagree whether an explosion like this might affect him significantly. For example, according to some accounts, then explosions of rays rose, really capable of making a serious and noticeable impact on living creatures on Earth over hundreds of millions of years. One of these flares may be the cause of a major mass extinction. But science is more keen to investigate nature. Such explosions continued. It was imposed as a rule. Supernova explosions usually occur after the collapse of a really massive star, or when two neutron stars merge and collapse together into a black hole. A gamma-ray burst event is no different. A lot about the supernova event. Supernova, in this regard, since both involve the gravitational collapse of the star's core, so the difference lies in the results. If a star exists, it turns into a supernova, a solid layer that moves at a speed ranging between 10 and 30 kilometers on the second. For gamma-ray burst, something emitting gamma rays practically travels at the speed of light. It is unlikely that such an event will occur anywhere near us. Assuming this is true, a huge amount of large-scale events may occur. Likewise in the universe. He spoke One of them could be a star that turns into a supernova. It is apparent when the density of the apparent size of the star increases from 10 to 20 times. This process is the ultimate destructive event, which occurs at the end of the evolution of some stars. It is accompanied by the release of accompanying a supernova event, emission of large amounts of matter from the layer, the exterior of a star in interstellar space. If the mass of the star before the explosion, more than 8 solar masses combined, a compact body is formed from the remaining matter of the star. This body is called a neutron star. If the mass of the star is greater than 40 solar masses, the black hole is supposed to appear after the explosion. As for the composition of these emissions, there is a large percentage of thermonuclear products. Remnants of the nuclear process occur throughout the entire life cycle of a star. Thanks to these supernovas, the universe in general and each galaxy in particular evolves chemically. And without specifying what I told you about the nature of these events, it is largely theoretical assumptions. Humans have not observed these processes up close, therefore, he cannot make specific statements about its nature. However, this is due to the development of stellar astrophysics. Science is moving forward dramatically. It reveals things that were unheard of in the past. Who knows? With the passage of time, perhaps we will become closer to understanding more complex matters.